This episode is sponsored by Thimble and Brush Co. Thimble and Brush Co. makes one-of-a-kind, soft, comfortable, meticulously designed apparel and handmade decor so you and your home can look their best in unique style.
I'm so excited to have them as a sponsor because I actually found them on Instagram before we partnered with them, and I fell in love with their stuff. It is just so cute. I love the aesthetics, the color palette she uses. I wish I could buy everything in the shop and wear it all and decorate my home with it.
Their shop is www.thimbleandbrushco.design. If you go check it out, and if you see something you like, no matter how many things it is, you can get a discount of 15% by using the discount code CHEM4LIFE. So that's CHEM, the number 4, LIFE at checkout. And now on to the show.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast that helps you understand the chemistry of your everyday life.
Jam, how are you doing?
I'm doing really great. I'm drinking coffee. I'm loving it, and it's great.
Ready to live and learn.
Yeah, live, laugh, learn, love, drink coffee.
Oh, no. Well, I'm excited for today's topic. I think usually I am.
Yeah.
But this week I had a really hard time coming up with the topic because it was so hard to follow up this super exciting episode with Renee.
Yeah, that's true.
It was very hard to decide, but I finally was like, well, a lot of people, my brother, my roommate, a few other people in passing, I can't remember, specifically asked about carbonated sodas, carbonated water beverages.
Uh-huh.
I was like, I'll do this. I kind of know it already. It'll be good enough, whatever.
Yeah.
And then when I started looking into it, it got crazy. It took twists. It took turns. There's a familial element that blew my mind. It was so fun.
Uh-huh.
So now I'm really excited, and I think this is the perfect follow-up episode to Renee.
Nice. Excellent. That's very good. We might have caused ourselves a problem by having such a cool episode. Like maybe in the future we should think twice about having really cool episodes because we might have a hard time following them up with other episodes.
I agree.
So,
especially because I'm the one that has to come up with.
Yeah. Yep.
It's tough.
It's you just carry it. Yep.
Okay. So let's get started. I love Spindrift.
Uh-huh.
It's a type of sparkling water.
Yes, I'm familiar. And I know how much you love it.
I love it so much.
You kind of can't not tell people about it.
I can't not tell people about it. I'm so excited about it. It's fresh fruit squeezed into sparkling water. You know this, but the people at home might not.
Yeah.
And it's so flavorful and delicious, and it doesn't have any of the weird chemically aftertaste that other, quote, lemon flavored sodas that are made with no lemon juice do.
Right.
And you can tell that it's real fruit juice because it has like 2 or 3 calories per can instead of being mysteriously 0 calories, even though it has a flavor.
Yeah.
Things I'm suspicious of include that. So I love it. It's just sparkling water with fruit juice. And I was going on and on about how much I love it. Mm-hmm. And my brother said, listen, I know it's just air. I don't know how to explain it, but I think carbonated water has a bad taste.
Huh.
And I said, you're right. It does have a bad taste because there's a chemical reaction happening.
Well, it's not a bad taste. I mean, I guess you could say you might think it's bad.
Right.
It has a taste.
It does have a taste.
And some people like it, some people do not.
Some people like it, some people do not. I love it.
Me too.
In the right context with the right stuff in it.
Yeah.
So I said, you're right. There's CO2 dissolved in water. And we talked about on the baking soda and baking powder episode how when carbonic acid breaks up, it breaks into CO2 and H2O.
Uh-huh.
That is actually what's known as a reversible reaction.
Uh-huh.
So the opposite can happen where CO2 and H2O come together to make carbonic acid.
Oh.
So there's a little bit of that carbonic acid flavor in your drink.
Okay.
My brother was amazed.
Yeah.
He was like, seriously? And I had learned that in college a long time ago, and it was buried so far back, and I just kind of think everyone knew it. Or thought everyone knew it.
Buried under a pile of other things you've learned.
Right.
Yeah.
Yeah. So I was like, yeah, that's it. That's how soda water works. And he said, you have to do an episode on that.
Yeah.
Because that's amazing. He was so frustrated for so long because he said it's illogical for air to have a flavor. So,
yeah, right. He knew just enough to be frustrated.
Right.
Like, I think most people don't think about it. They either like it or they don't, but they're not like, why does it taste like this? You know?
He was like, it's just water and air. It shouldn't taste any different, but it does.
Yeah.
And I was like, well, it's not water and empty air. It's water and CO2.
One good thing, I think, is that if Spindrift ever decides to sponsor our podcast, we could basically take most of what you said at the beginning of this and just use it.
Oh, absolutely.
Fade it right into a really nice ad for them.
Spindrift, if you're out there, if you're listening, please sponsor us. We love you.
And we'll say what we already said, or we'll say whatever you want.
So that was that. That's basically the reverse reaction of the CO2 and water happening. Man,
it's been a while since we did that episode too. I'm gonna have to
think
really,
through it.
Remember stuff.
Well, and the reason it can happen reversibly is because there's something known as equilibrium, where really molecules are moving around so much that it's not like this plus this, A plus B just equals C. A lot of times A plus B equals C, and then C is breaking back up into A plus B, and then A plus B is reforming. It kind of just goes back and forth as the molecules move around and energy is put in and given off. So usually reactions will favor one side or the other. They'll tend to go more one direction than the other. There's a lot of stuff that goes into that doesn't really matter, but just know that reaction is reversible, and we talked about it already. The atoms in carbonic acid can break up and rearrange to form CO2 and H2O in the same way that CO2 and H2O can combine to form carbonic acid.
Okay.
It's just a reversible reaction.
Okay.
So that's the first part.
Okay.
That's all I thought there was. I learned that in college. But I always check my facts before I come in to do an episode.
Yeah.
So I was pulling up some stuff to basically confirm what I already knew. And I discovered that a few months after I graduated college, a new paper came out with a new finding that told me that CO2 detection was totally different than anything I thought.
Really?
It was amazing.
Wait, CO2, you said CO2 detection?
CO2 detection on our tongue was way more complicated than I ever thought.
Interesting. Okay.
So are you ready?
Yes, I'm ready.
Buckle up. I'm so excited. It was like, science is still working. Since I left college, new things have come out.
Yeah.
I've never revisited this since I got to grad school because there's not really a point.
Yeah.
But my mind was blown.
That's cool. And it also makes it more fun for you in this case. You're not just
so
recycling.
Much more fun.
Yeah. Not just recycling old info. You're getting to kind of share new info with everybody.
Yeah. I'm so excited. Okay. Before we go into the new part though, do you want to kind of give a brief overview of what I just said?
So like in the baking soda, baking powder episode, in that case, it was that there is acid and it breaks apart into H2O and CO2. And in the case of sodas, what you had learned, carbonated water, what you had learned a while ago and kept in your memory was that it's basically the same thing in reverse, that it is what happens when H2O and CO2 are together, that they form that same type of acid. You said it's carbonic acid?
Right.
Okay. So it's like either direction. The acid's there, and then it can break apart into those two things, or those two things are together, and they can combine to create that acid.
Right.
Okay. Got it.
And so that is, the CO2 comes from, they pump CO2 into water to make it carbonated, store it under pressure, but it can react with water to make the carbonic acid.
What's so weird to me, I mean, maybe this is not going to seem weird in a second. I've just never really thought about it, but how can you just force some gas into some liquid?
Well, actually, gas is more soluble when liquid is cold and when it's under pressure. So that's why we keep our drinks in the fridge with the lid on, cold and under pressure.
Yeah.
So it's soluble under those conditions. And actually, I suspect, but have never confirmed, that bottles, like a bottle of Dr. Pepper, can hold a little bit more pressure than a can of Dr. Pepper can, because I don't like how fizzy the bottles are compared to the can.
Interesting.
I've never confirmed that, but I think they just keep it under higher pressure.
I've never noticed that difference, but I haven't really thought about it. But I guess they're definitely different materials. I mean, very, very different. So that might make sense. But that is so weird.
Yeah.
Just forcing some gas into some liquid into a container.
I planned to look into how they did that manufacturer-wise, and I never got around to it. I think it's going to have to be another episode because this by itself is pretty complex.
Okay, so potentially part 1, but even so, on its own important topic.
Right.
Okay.
So you've got a good handle on the basics. It's the reverse reaction that acid forms when the carbonation, the CO2 that's dissolved in the water to make our drinks fizzy, sometimes has a little bit of a reaction to make carbonic acid.
Okay.
We can put the pictures up of the atoms rearranging the same way we did for the baking soda, baking powder episode.
Okay.
So here's the new thing that came out. I'm so excited about this. What they found was we are not just experiencing bubbles bursting and tasting a little bit of acid on our tongue when we drink fizzy drinks. What's actually happening is there is a CO2 receptor on our tongue that senses the CO2. It's an enzyme called carbonic anhydrase 4, for those who want to know. It's attached to the sour receptors on our tongue, sort of like a little flag waving around. And when the CO2 comes, it breaks it down into carbonic acid along with water. So there is the sour taste, but also there's a sensory message that's activated that feels like bubbles on our tongue. And this whole time I thought I was feeling bubbles on my tongue, but if you drink carbonated beverages in a pressure chamber where the bubbles cannot burst, you still experience the same fizzy sensation.
And our tongues are what's sort of making the acid come about as well.
Yes.
Like you said that first, and that is surprising to me. Because it seemed like if that wasn't happening on our tongue, that enzyme wasn't doing what it's doing, that it might not taste that way.
Yes.
And then we also wouldn't feel the bubbles.
Yes. Isn't that crazy?
What the heck?
I know. It's like a twofold. First of all, there's more acid sour taste than there would be because of the CO2 detectors on our tongue or enzymes on our tongue. And second of all, that feeling is a sensory response to the chemical, not necessarily the actual feeling of bubbly water.
Yeah.
Isn't that mind-blowing?
That's so weird. I've never thought about it, but I mean, I guess, what would bubbly water, I mean, we see the bubbles in the carbonated water or in the soda or in the whatever it is.
Right.
And it is kind of weird to think that we would feel those at all in the first place.
Right.
Like, what it would even feel like? What we feel is pretty strong.
Yep.
It doesn't really feel like a bubble.
I know. And I was trying to envision if I poured it over my hand, does it feel like fizzy water?
Yeah.
And I was like, no.
Yeah.
Yeah. My mind was blown. So
Okay.
I'm here to officially apologize to my brother because I spread old information and I was wrong and he was right. Carbonation itself, the CO2, has a flavor.
Yeah.
And I was wrong. It has a sensory response in our tongues and I was wrong. It's not just the acid in the water. There's more to it.
Yeah.
So I'm here to formally apologize and admit I was wrong to my brother on a public forum.
Dean, that's crazy. Something so simple. I mean, I'm not really sure how they found out about carbonated water or whatever.
Well, I can tell you about it.
Oh.
Are you ready for that?
Yeah, let's just do that instead of what I was going to say, which was just another version of, wow, it's crazy. Wow, everything about the world is mind-blowing to me because I don't know anything.
Well, I can tell you one who invented carbonated water, and I can tell you two.
Yes.
How they figured this particular thing out.
Okay, I'm ready.
Okay, so the person who invented carbonated water is a relative of someone you and I know.
No, wait.
You and I know them personally. Our listeners do not. Most of them, probably.
A relative of someone you and I know personally?
Mm-hmm.
No.
Yes. Our good friend, Autumn Priestley,
Uh-huh.
went to UNT with you. She and I worked together at our church for a few years.
Uh-huh.
Autumn Priestley's great uncle, someone we personally know's great uncle, was a famous chemist named Joseph Priestley, and he invented carbonated water as a misguided attempt to fix scurvy.
What?
Yeah, it didn't fix scurvy because scurvy is a vitamin C deficiency. But isn't that so cool?
Yes. What? So Autumn, thank you so much to your great uncle or whatever.
I know. In 1767, I think.
That is so crazy. So he was trying to solve a very real problem.
Yes.
Do we know what tools he had at his disposal that ended up causing that initial version?
Didn't look into any of that. Just freaked out that I knew that person's descendant, and that was it.
What if he caught a lot of CO2 in his mouth and then just blew it really hard into a bottle that had or a jar or whatever that had the water in it? And what if it was just a little fizzy? He was like, huh.
I have no idea.
Okay.
I have no idea. Maybe
it could have been that.
Maybe someone who likes the science history can go look into how Joseph Priestley came up with that. I did not have time to do it, and the semester starts tomorrow. So that's the first crazy part.
Okay.
Second crazy part is the way that these scientists did it. I'm not sure. I was kind of confused on how exactly they figured out that they should do this. And I cite the original article in our resources where they discovered this in 2009. But first, they inhibited the CO2 enzyme. So somehow they detected the CO2 enzyme. First, they inhibited it.
Yeah.
And noted that no other flavors were inhibited. So you could still taste sour, sweet, all those things.
Yeah. The flavor of fruit flavor, whatever it is, that's part of the thing you're drinking.
Regardless of the fact that the CO2 enzymes are blocked.
So that's awesome that they could do that.
Right.
Whoa.
And then the second thing that they did, they did these tests on mice because mice have a very similar taste palate that we do. And they basically genetically engineered mice to not have sour receptors at all. And the mice that didn't have sour receptors also did not have CO2 detection abilities. So the CO2 functions independently of the sour receptors because they could still taste sour when CO2 was inhibited. But it's directly attached to the sour receptors because if the sour receptors are gone, so is the ability to detect CO2.
Interesting.
So one article I read described it like the CO2 enzyme is a flag on the sour receptors almost.
So they are kind of one, even though they do different things to some degree. We can obviously taste sour even when it's not carbonated or whatever.
Right.
But they are one thing, sort of. Sort of.
It's attached.
Yeah.
So if you don't have sour receptors, you don't have a CO2 detector. But if you inhibit your CO2 detector, you can still taste sour things.
Interesting.
So weird, right?
That's really weird. What?
My mind was blown. I was so excited.
So would all of the things, say they did it to a human instead of a mouse, we can't really ask the mice how they feel about it. What would it feel like to drink a soda? Or carbonated water? Would it just taste a little funky, but just be flat? I mean, we've all experienced a flat soda. Right. And I guess you could say that other tastes are the same, but it is
there might be a slight less sourness to it.
Okay, less sourness.
Because part of the sourness, as we learned, was the enzyme breaking down the CO2.
Or the sourness is weird. Have you let a carbonated water that has a little bit of fruit flavor go flat?
No.
It tastes it just tastes weird.
I think they probably balance it for the sour in the gas in addition to the sour that naturally forms in the soda. So when part of that equation is gone, the other flavors get out of balance, sort of.
Yeah.
To our tongue.
Right. And our experience of drinking them is so tied to the feel as well.
Right.
Even if it actually does taste the same technically.
Right.
If you could prove that, it obviously feels so different that it doesn't really matter. Obviously, we like that feel.
That's missing why we
go for it.
They called it a somatosensory cell. So we're missing the activation of the somatosensory cell that gives us the sensation of the bubbles.
Wow.
So we need both.
Yeah.
You're activating both your somatosensory receptor and you're activating your sour receptor at the same time. You're getting the taste and the feel. And the feel is part of that signaling reaction from the enzyme being broken down.
Wow.
Isn't that crazy?
That's really crazy.
Do you want to try to explain it back to me?
Yeah, I'll try my best. I'm a little bit in awe and also so confused because I don't know much about the tongue in general. So
Right.
it's like, all this is totally new to me.
It took me a second. I had to reread a few times. Yeah. I was amazed. And then I read an interview with one of the people who wrote the paper, and that gave a little more information. So it was very interesting. I had so much fun researching this.
Okay, so back in the Wild West, Dr. Pepper and Billy the Kid were... Just kidding. So carbonated things have the acid already in it. The carbonic acid is already in it.
It can just form as a byproduct of CO2 and water reacting.
Okay,
So there can be some already in it.
because it's already reacting, we're seeing that, right? By the bubbles, like, happening.
The bubbles happening are just the CO2 that's dissolved as they come out of solution.
Okay, so that's not a reaction. It's just it's there. So we take a sip. We have a part of our tongue that's not just our sour receptor area, but also the, what'd you call that? The
CO2 enzyme.
enzyme, CO2 enzyme.
The official name is carbonic anhydrase 4.
Okay. We have that. It's just attached to our sour receptors.
Right.
And while we're tasting what we're drinking,
Yes.
also the enzyme is affecting the thing that we're drinking to where it, oh gosh, it is reacting
Right.
and making more of the carbonic acid.
That's a great way to put it.
Okay.
It's basically like the enzyme helps the formation of carbonic acid, which is protons, basically. I mean, that's not super important for people to know. It just gives us that acidic flavor.
Okay. And so that's happening while it's going across our tongues.
Right.
And so we're tasting it and and it's changing while it's going across.
Yes.
And we're feeling it because while that's happening, a feel happens, the bubble feeling happens as a result of the enzyme doing its deal.
Yes. So it seems like when they break down that CO2, the enzyme is activating not just a sour receptor, but also a somatosensory cell, or almost like a feeling cell. So it gives us the bubbly sensation.
Okay, somatosensory. Now that makes sense. The sensory part. I see what you're saying now. Okay. Man, that is so crazy.
Isn't it?
Yes.
I really, this is almost exactly like the onions episode for me, because I went into this
Oh, yeah.
very confident. I was like, I know what happens. You put carbonation in water and a little bit of acid happens
Bada
just
bing.
naturally, and we can kind of taste it. And it's like, no, actually our tongue can break down CO2.
Yeah.
It's crazy.
That is so crazy.
Yeah.
If anyone out there who doesn't like carbonated stuff or has never had it, this is totally boring for you guys. So sorry. Maybe you'll be interested now though.
And go get a Spindrift.
I do know some people who aren't super into carbonated stuff. I don't know what the deal is.
He hates it.
He hates all of it.
He did like soda, but I think
No, he
that's all
doesn't.
the other sugar and stuff in there. Yeah.
Got it. Yeah. I have a friend who doesn't like anything carbonated no matter what. It doesn't really have like it's not good for you or whatever. He just doesn't like it.
I wonder if those people have more of the CO2 detectors. Boom.
I also used to have a boss who used to like carbonated stuff and has a medicine that she's pretty convinced has an effect on the taste of carbonated stuff, which maybe is affecting this somatosensory thing, or maybe affecting the enzyme. I don't know.
Dang, that's crazy. Oh, I was going to say that at the end of this article, the scientist spent a little bit of time speculating on why mammals have CO2 sensing. Like, why do we have this on our tongue?
Yeah.
And they don't, obviously, or didn't in 2009, have a clear answer for it. But they felt it could have evolved as a mechanism to maybe recognize CO2 in food that's decomposing or fermenting that's not safe to eat.
Got it.
Or it could be that enzyme is there basically to produce the acid to keep the pH balance right around the taste buds. And we just detect CO2 almost as a byproduct that doesn't matter.
It's not about trying to taste it. It's about trying to fulfill another very important function of our bodies.
Right. That's what they suspected. So I should say pH is just the right amount of acid-base balance.
Yeah.
So that's what they suspected. It was either something that was evolved to help protect us, or maybe it's something that keeps the tongue where it needs to be, kind of.
Interesting.
Isn't that crazy?
Man, that's really cool. I love trying to obviously I know it's speculation. We can't probably really prove it very easily because it's not like we have a lot of humans from every period of like change to really observe, but that's pretty cool. And I think some of those things are kind of intuitive. You're like, well, not eating spoiled food, that seems like a really good thing for our bodies to try to have something to fight against, or just keeping our we know that like homeostasis,
right?
Like our body's trying to do that in a lot of ways constantly. Yeah. So just trying to keep the pH right of our tongues seems like it makes sense. So it's like, that's cool.
It's so fun. I love the things I've learned for this show, and I love when I end up being wrong about something. It's so fun. It's such a fun experience.
That is not what most people would say, but but that's okay. Okay,
so that's pretty much everything. Thanks for coming and learning and caring about carbonation.
Anytime. I already love it, so now I just know more about it and love it even more.
Yeah, now you can think about this the next time you're drinking your fizzy drinks. Okay, so do you want to say something that made you happy this week?
I do. I would love to. So I already talked about seeing my family. That was a happy thing, I think, for the previous time, maybe something like that.
A few weeks ago.
So what I'm going to share about is that of what I got for Christmas from them. So they all chipped in together to get me a new coffee grinder, which I've really been wanting.
Yeah.
I've had the same coffee grinder. I mean, I'm way into coffee. And so slowly improving one's coffee setup is kind of the name of the game across time. And the grinder, which I think could have a way of like translating into chemistry, is so important because it's one of the first steps before anything else happens. Not other than just getting coffee, you know?
Right.
Grinding the coffee and the particle size and having good options and consistency in it makes a huge difference. And so I'm really excited. I'm going from the ability to grind 16 different levels of coarseness, fineness and coarseness, to now being able to grind 40 different ones. So I can be way more specific. And so I'm really excited about that. And that was super, super cool of my family. And I loved
super, super cool
getting to hang with them. And I love the grinder.
Jim is a scientific person in his own right regarding his coffee. But don't worry, we are planning on doing a series on coffee. It is oft requested. We hear you, but we want to give it the time and space to do it just right.
And I also want it to happen so badly. Of all the things that we could talk about, I want coffee to happen.
We're not going to just do it halfway. We're going to try to do the best we can do with it.
It's a worthy topic. I obviously feel that way.
I think it's going to have to be a multi-part, like month-long series about coffee or
That'd
something.
Be so cool. I mean, everybody cares about coffee, even if not everybody likes coffee the same way.
Right.
We all have some, coffee's in all of our lives, whether we like it or not.
That's true.
So
even when I didn't like coffee, I loved how it smelled.
Yeah.
Okay, one really cool thing that I did that I love so much on January 1st, I went with my dad to the Winter Classic. So that is an outdoor hockey game that the NHL puts on once a year. And it can be
outdoor.
Yes.
Interesting.
And it can be anywhere, any team. Usually it's in the north, and it's some really traditional hockey team. So this is
go ahead and do it at a pond that's already frozen.
Yeah, that's it.
That kind of thing.
No, they do regulation ice. But this year they did it in Dallas, which is the furthest south it has ever been.
Whoa. And
everything went so well. I had such a fun time with my dad. And it was like, oh, this is a moment of sports history. There was the second largest crowd the NHL has ever had at any game ever. And it was so fun to be there with so many people who were excited about the same thing you were. And it just was a shared sense of camaraderie that was really enjoyable. And it was such a good day with my dad. Just all day, all we did was hockey and hang out and ride the train there. And they opened the fairgrounds, so we got to do a Foster's corn dog. I'd never had one before.
Oh, nice.
It was so fun. And then I went home and was in bed by 7 p.m. So
wow.
It was kind of a perfect day.
Yeah, that's incredible.
So I think I got in bed that early because I ended up being sick, but it was, I didn't know it yet then. So it was so fun and just a really special time with my dad. So
that's cool.
Yeah. That's it for this week for me.
So Melissa and I have a lot of ideas for topics of chemistry in everyday life, just like carbonation. So we want to hear from you. If you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, and Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you enjoyed this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people. If you'd like to help us keep our show going and contribute to the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee.
This episode of Chemistry for Your Life was created by Melissa Collini and Jan Robinson. References for this episode can be found in our show notes and on our website. Jan Robinson is our producer, and we'd like to give a special thanks to A. Hefner and A. Collini, who reviewed this episode.